Hello everybody, in today's video we're going to go over some of the basics of acids and bases, their different definitions, the conjugate forms of each, and what happens if something can be an acid and a base at the same time. Stay tuned. Now the first thing I want to talk about are the different kinds of acids and bases and the ways that we can look at them. So the first way is we can take the concept of Arrhenius acids and bases. Now this is our classic example when we think about acids and bases. Arrhenius acids, when we put them into water, this is going to increase our hydrogen ion concentration. And what this does is it's going to decrease the pH. As we know, as hydrogen ion concentration increases, the solution becomes more acidic, decreasing its pH. Now the opposite is true for Arrhenius bases. These, instead of increasing hydrogen ion concentration, they'll actually increase hydroxide concentration. And what this does is the opposite. This will also increase the pH, because we know as hydroxide concentration increases, the pH will also increase, making the solution more basic. Now, another definition that we can use when talking about acids or bases is the Brønsted Lowry concept. In this concept, we're talking about a substance's ability to either donate a proton or to accept the proton. Now, when we're talking about Brønsted Lowry acids, these are going to be what donate protons. So they're going to give away that hydrogen ion. Something else is going to pick it up. So if we take, for example, here, hydrogen chloride, and we put it into water, that hydrogen chloride is going to give one of its hydrogens to our water to create hydronium, and it's also going to be left with just that Cl. So this Brønsted Lowry acid, hydrogen chloride, gives one of its hydrogens to water, creating hydronium, and all that we're left with from here is that chloride. Now, when we're talking about bases using the Brønsted Lowry concept, this is basically just what accepts that proton. So these will take it, they'll add it to them. They're going to accept that hydrogen. Now in this example, again here, so we can take NH3, and then when we mix that into water, it's not going to give away one of its hydrogens. In this case, when we're talking about the base, it's going to accept it. It'll take one away. So this will turn into NH4, and if we take one of the hydrogens away from water, all we're left with is hydroxide plus OH. So now we know that acids are going to donate protons and the bases are going to be what accept those protons. The next thing I want to discuss is the idea of conjugates. So when we think of conjugates, we can think of an acid or a base and just whatever the opposite of that acid or base is. Let me explain. If we take hydrochloric acid, as it says in the name, it's acidic, it's an acid, meaning that it's going to be able to donate one of its hydrogen protons. So each acid is going to have a conjugate base, and each base will have a conjugate acid. So the conjugate base for hydrochloric acid is going to be that substance when we take away a hydrogen ion. So in this case, the conjugate base will simply be that chloride. Because when we start with that acid and we take away the hydrogen, that's what's going to give us our conjugate base. Now, the same is true for bases. We know bases will accept the hydrogen proton. So if we take ammonia here, for example, and we add a hydrogen ion to it, the conjugate acid is going to be this plus that hydrogen ion. So in this case, we get ammonium as our conjugate acid. This is going to be very needed when we're thinking about whether solutions are acidic or basic. So this is our conjugate acid. We see here acids are always going to have a conjugate base. Without that hydrogen, and bases are going to have a conjugate acid when we add a hydrogen proton to it. Now, here's an interesting question I have for you. Can a substance act as both an acid and a base? It sounds counterintuitive, but yes, it can. And those substances we call Amphiprotic. What this basically means is that that substance, depending on what we mix it with, could either act as the base or the acid. So one example that we're going to see a lot of in chemistry too, and it's a good example for understanding this situation, is water. H2O can actually act as both an acid and a base. So to show first, let's take H2O and let's mix it with hydrochloric acid. We know hydrochloric acid is a strong acid, meaning it's going to want to give up its hydrogen. So when we do that, this H2O water is going to act as a base. It's going to accept one of the hydrogens from hydrochloric acid. So that will now turn into hydronium, H3O+. When we do that, that HCO, we're just left with the chlorine. So here we see how water can act as a base and accept one of the hydrogen ions from HCl. However, if we mix water with something else, it could act as an acid. So let's see here, if we take H2O and we mix it with ammonia, NH3. Now we know ammonia is a base, meaning it's going to accept protons. And where is it going to accept it from? From water. So in this case, that ammonia is going to turn into NH4, and that hydrogen is going to act as an acid and donate one of its hydrogen ions. You can write that as acid. In this case, it's acting as an acid. And when we take one of the hydrogens away, what we're left with is hydroxide. Now here we have an example of water as acting as both an acid and a base, making it an amphiprotic substance. Thank you for watching today's video on Acids and Bases 101. I know today we did not go into a lot of in-depth details. It's why we're a more simple shirt today. But if there's anything that you'd like to see me cover, or if you have any questions, please let me know in the comments below and I'll get back to them as soon as I can. Have a great day. Acid and a base, making it an amphiprotic substance.